Mars, the red planet, a world that's captivated humanity for centuries. From its rusty deserts to its towering volcanoes, Mars feels both familiar and utterly alien. But here's the thing, even with all our advanced technology, with rovers crawling its surface and orbiters mapping every inch, Mars still holds secrets that defy explanation. Think about that for a second. We've sent machines to another planet, drilled into its soil, even flown a helicopter in its thin atmosphere, and yet there are phenomena on Mars that leave the brightest minds on Earth scratching their heads. Picture this: strange lights flickering in the distance, formations that look eerily artificial, even seasonal changes that science can't fully account for. And that's just the beginning. Today, we're diving into 30 of the most puzzling mysteries Mars has thrown at us, 30 phenomena that stubbornly refuse to be solved. Some of these might make you question everything you thought you knew about our planetary neighbor. Others will leave you wondering if we're truly alone in the universe. This isn't just a list of oddities, it's a journey into the unknown, a glimpse at the edges of human understanding. Because Mars isn't just a barren rock, it's a world teeming with questions, each one more fascinating than the last. So buckle up, by the time we're done, you'll see the red planet in a whole new light, and maybe, just maybe, you'll start to wonder what else is out there waiting to be discovered. The first mystery on our list is one that sparked imaginations worldwide, the so-called face on Mars. Back in 1976, NASA, a Viking 1 orbiter, snapped an image of a region called Cydonia, and what it captured sent shockwaves through the scientific community and beyond. There, amid the barren landscape, was what appeared to be a massive humanoid face staring up from the Martian surface, nearly 2 miles across, with shadows creating the illusion of eyes, a nose, even a mouth. It looked eerily like a monument carved by intelligent hands. At the time, the idea of an ancient Martian civilization wasn't just fringe speculation. It seemed almost plausible. Could this be evidence of a lost culture, a monument left behind by beings who once called Mars home? Theories exploded, from elaborate hoaxes to whispers of government cover-ups. But as with many Martian mysteries, the truth turned out to be both simpler and somehow just as fascinating. Decades later, with far better cameras like those on the Mars Global Surveyor, we got a clearer look. High-resolution images revealed the face was nothing more than a windswept mesa, a natural rock formation sculpted by time and weather. The shadows that once gave it such striking detail, just tricks of light and angle, a cosmic case of pareidolia, the same phenomenon that makes us see shapes in clouds or faces in toast. Yet, here's where things get interesting. Even with the debunking, some researchers and enthusiasts aren't convinced. They point to oddities in the newer image's symmetrical features, apparent geometric patterns nearby, and argue that erosion alone can't explain everything. Could there still be something unusual about Cydonia, or is this a testament to how powerfully our minds search for meaning, even in the rocks of another world? One thing's for sure, the face on Mars reminds us that Mars doesn't just challenge our technology, it tests our perception. What we see isn't always what's there, and sometimes the biggest mysteries aren't on the planet's surface but in how we choose to interpret them. Moving from the towering mysteries of Cydonia to something far smaller but no less intriguing, let's talk about the Martian blueberries. These aren't the kind you'd find in a grocery store. Instead, they're tiny, spherical formations scattered across the surface of Mars like cosmic ball bearings. Discovered by NASA Opportunity rover in 2004, these peculiar objects immediately stood out against the rusty backdrop of Meridiani Planum. Roughly the size of BB pellets, or yes, actual blueberries, they littered the landscape in clusters, sometimes embedded in rock, sometimes loose on the ground. What makes them so fascinating isn't just their shape, but what they're made of: hematite, an iron-rich mineral that often forms in the presence of liquid water. Scientists call them concretions, nodules that develop when minerals precipitate out of water and cement together over time. On Earth, you'd find similar formations in places like the Utah Desert or the Australian outback, where ancient groundwater once flowed. That's why the discovery sent ripples through the scientific community. These blueberries weren't just geological curiosities. They were potential proof that Mars once had a wet, watery past. But how exactly did they form? The leading theory suggests that acidic groundwater percolated through Martian bedrock, dissolving iron and other minerals. As conditions changed, perhaps as the water evaporated or its chemistry shifted, the iron oxide concentrated into layers, building up sphere by sphere over thousands or even millions of years. The result, perfectly rounded little time capsules, preserving clues about the planet's environmental history. Now, here's where it gets even weirder. Not all blueberries are created equal. Some are densely packed like beads, others have a more weathered, pitted appearance. Some regions show them fused together in grape-like clusters, while elsewhere they're scattered like spilled marbles. This variety hints at complex, changing conditions, maybe fluctuating water levels or shifting acidity, that shaped Mars over eons. And then there's the big question: what does this mean for life? Liquid water is one of the key ingredients for life as we know it, and if Mars had enough groundwater to form these hematite spheres, it might have also had the right conditions for microbial organisms. Could these blueberries be more than just geological artifacts? Could they be markers of a habitable Mars, a world that once teemed with hidden possibilities? Of course, not everyone agrees on every detail. Some researchers argue alternative explanations, like volcanic processes or even meteorite impacts, could have contributed to their formation. But the water theory remains the strongest, supported by their uncanny resemblance to earthly concretions. What's undeniable is that these tiny spheres tell a gigantic story, one of a Mars that was far more dynamic, far more Earth-like than the frozen desert we see today. So the next time you picture Mars, don't just imagine red dust and empty plains. Think of those blueberries, silent witnesses to a lost era when water flowed, conditions shifted, and maybe, just maybe, something stirred beneath the surface. Because sometimes the smallest things hold the biggest secrets. Now, let's shift our focus from tiny mineral spheres to something far more dynamic, those mysterious dark streaks that slither down Martian slopes like shadowy fingers reaching into the valleys below. These are the recurring slope lineae, or RSL for short, and they've been one of the most tantalizing and debated phenomena on Mars since their discovery in 2011. Picture this: steep crater walls and canyon faces bathed in sunlight, suddenly marred by dark tendrils that appear, lengthen, then fade with the seasons. It's as if Mars itself is breathing, its surface shifting in ways we're only beginning to understand. First spotted by NASA, a Mars Reconnaissance Orbiter, RSL are narrow, dark streaks that emerge during warmer months, extending downhill before vanishing when temperatures drop. At first glance, they look like the aftermath of tiny landslides or maybe even trails left by trickling water. And that last possibility, that's what sent shockwaves through the scientific community. Because if these streaks were caused by liquid water, even hyper-salty, barely liquid water, it would mean Mars isn't just a frozen relic. It would mean that today, right now, water might still flow in some form on its surface. The initial theory was compelling. Scientists proposed that subsurface ice could melt in the Martian summer, forming briny liquid that seeps to the surface, darkening the soil as it trickles downslope. The chemistry made sense. Salt lowers water's freezing point, allowing it to stay liquid in Mars' frigid, thin atmosphere, and the implications were staggering. If liquid water exists seasonally, even in trace amounts, it could reshape our understanding of Martian habitability. Suddenly, the search for microbial life wasn't just about ancient history, it was about the here and now. But then came the curveball. In 2017, another team analyzed the data and proposed a radically different explanation: dry sand flows. Their argument: the streaks might simply be avalanches of fine-grained dust triggered by temperature changes or gusts of wind. Instead of liquid water carving those dark paths, it could be nothing more than grains of sand cascading downhill, uncovering darker material beneath. Supporting this, some RSL appear on slopes so steep that liquid would struggle to cling to the surface without boiling away in Mars' low-pressure air. So which is it, water or wind? The debate still rages. Proponents of the water theory point to spectral data suggesting hydrated salts in RSL regions, compounds that could only form in the presence of liquid. Critics counter that similar dark streaks appear in bone-dry deserts on Earth, where shifting sands create nearly identical patterns. Meanwhile, new observations complicate things further. Some RSL don't align neatly with either theory, showing behavior that defies easy explanation. And then there's the life question. If RSL are watery, even intermittently, they'd be prime targets in the hunt for extremophiles, hardy microbes that could survive in Mars' harsh environment. But if they're dry, the search gets tougher. That's why RSL aren't just a geological curiosity. They're a crossroads in astrobiology, a puzzle that could redefine where and how we look for life beyond Earth. One thing's certain: these streaks are more than meets the eye. Whether carved by water or shaped by wind, they're proof that Mars is still an active world, changing before our very lenses. And until we can sink a drill into those slopes or catch a droplet in the act, the recurring slope lineae will remain one of the red planet's most compelling open questions, a reminder that some mysteries refuse to stay neatly solved. Mars holds another enigma, one that comes and goes like a ghost in the data, appearing just long enough to intrigue us before vanishing without explanation. This is the methane mystery, a puzzle that's been confounding scientists since the first whiffs of the gas were detected in the Martian atmosphere. Methane, a simple molecule made of one carbon atom and 4 hydrogens, shouldn't be all that exciting. But on Mars, it's anything but ordinary, because here's the thing: methane doesn't stick around for long. Sunlight and chemical reactions break it down within a few hundred years, so when we detect it, that means it's either being replenished or it was released very recently. The Curiosity rover first spotted methane spikes in 2013, with levels occasionally jumping to 10 times the background average. Then, in 2019, the European Space Agency's Trace gas orbiter made a startling observation: a methane plume so vast it couldn't be ignored. But just as quickly as these signals appeared, they dissipated, leaving researchers scrambling to explain the inconsistency. It's like trying to catch smoke with your bare hands. Every time you think you've got a grasp on it, it slips away. So where's this methane coming from? That's where the debate gets fierce. On Earth, the vast majority of methane is produced by living organisms, everything from bacteria to cows. That's why the discovery sent astrobiologists into a frenzy. Could these whiffs of gas be the signatures of Martian microbes quietly thriving beneath the surface? It's not as far-fetched as it sounds. Underground, shielded from radiation and extreme temperatures, microbial life could theoretically produce methane as a byproduct of metabolism, just like it does in Earth swamps and landfills. But before we jump to aliens, there's another possibility: geology. Methane can also be produced by non-living processes like serpentinization, a reaction between water, carbon dioxide, and certain minerals deep underground. Mars has plenty of volcanic history, and though we haven't spotted active eruptions, residual heat could still drive these reactions. Even meteorites falling onto the surface might release methane when they vaporize on impact. The problem: no single geological explanation neatly accounts for the sporadic, localized nature of the detections. Then there's the measurement challenge itself. Detecting methane from millions of miles away is like trying to sniff a single candle in a football stadium. Curiosity's instruments are incredibly sensitive, but they've also produced head-scratching contradictions. The rover often measures spikes while orbiters flying overhead see nothing, and vice versa. Some scientists argue these discrepancies could be due to atmospheric conditions. Methane might disperse or become trapped near the surface in ways we don't yet understand. Others wonder if the rover itself is inadvertently releasing the gas, though rigorous testing has largely ruled that out. The mystery deepens when you consider seasonal patterns. Some data suggests methane levels rise slightly during Martian summers, hinting at temperature-dependent processes, maybe frozen methane clathrates thawing, or microbial activity peaking in warmer conditions. But again, the signal isn't consistent enough to draw firm conclusions. It's as if Mars is teasing us, offering clues just opaque enough to keep us guessing. What's at stake here goes beyond chemistry. If the methane is biological, it would be the most compelling hint of extraterrestrial life ever found. If it's geological, it still points to an active, dynamic Mars with hidden reservoirs of water or energy we barely understand. And if it's neither, if some unknown process is at work, then we're facing a gap in our understanding of planetary science itself. For now, all we can do is keep searching. Future missions like the Rosalind Franklin rover will carry even more advanced tools to sniff out methane and its potential sources. Until then, these elusive plumes remain one of Mars' most tantalizing riddles, a whisper of something extraordinary just beyond our reach. Imagine standing on Mars, the rust-colored landscape stretching endlessly around you, when suddenly the horizon begins to dance. A column of dust spirals upward, twisting and turning like an invisible hand stirring the heavens. These aren't just gusts of wind, they're dust devils, some taller than Mount Everest, carving paths across the Martian plains. While Earth has its own dust devils, the ones on Mars are in a league of their own. Caught on camera by rovers like Opportunity and Curiosity, these whirlwinds are both mesmerizing and scientifically invaluable, offering clues about the planet's atmosphere and even helping our robotic explorers survive. So how do these towering vortexes form in Mars' razor-thin atmosphere where the air pressure is less than 1% of Earth's? It starts with sunshine. The Martian surface heats up unevenly, creating pockets of warm air that rise rapidly through cooler layers above. As this air rushes upward, surrounding winds shear it into a spin, funneling dust and sand into a concentrated column. The lower gravity and thin atmosphere mean these vortices can grow to staggering sizes. Some stretch over 12 miles high, dwarfing even the most extreme examples on Earth. And without thick air to slow them down, they can race across the landscape at speeds exceeding 60 miles per hour, leaving behind serpentine tracks that linger for weeks. What's truly uncanny is how familiar yet alien they appear. Footage from rover cameras shows ghostly tendrils snaking across the horizon, their silhouettes crisp against the pale sky. Some seem almost deliberate, weaving between rocks like living things, but the real magic happens when these dust devils interact with human technology. Take the Spirit and Opportunity rovers. Their solar panels were constantly caked in dust, threatening to cut their missions short. Then, like cosmic janitors, dust devils would sweep by, their whirlwind motions scrubbing the panels clean. Opportunity, in particular, owes years of extra operation to these fortuitous encounters. It's as if Mars itself decided to lend a hand, or a whirlwind. Yet for all their helpfulness, dust devils also hold mysteries. Why do some regions, like the plains of Amazonas Planitia, host hundreds while others see almost none? Why do their trails sometimes zigzag unpredictably, as if guided by unseen forces? And could their behavior hint at larger atmospheric patterns we've yet to decode? Each rover image and weather dataset adds another piece to the puzzle, revealing a planet far more dynamic than its barren appearance suggests. Beyond the science, there's something haunting about watching these specters drift through the Martian wastes. They're reminders that even in stillness, Mars is alive with motion, a world where the wind writes its stories in dust, and every whirlwind carries secrets older than humanity itself. Among all the strange formations on Mars, few have captured the public imagination like the so-called doorway, spotted by the Curiosity rover in 2022. At first glance, it looks eerily deliberate, a near-perfect rectangle carved into the cliffside. Its edges so sharp and angles so precise that it's hard not to imagine some ancient civilization chiseling an entrance into the rock. The internet erupted with theories, secret alien bases, hidden tunnels, even proof that Mars was once home to intelligent beings. But as with so many Martian mysteries, the truth is both simpler and more fascinating than fiction. The doorway is actually a small fracture in the rock, barely taller than a house cat. Zoom out from the viral close-up, and you'll see it's just one of many cracks in a weathered outcrop, part of a natural geological process called shearing, where layers of sedimentary rock split under stress. Wind erosion then smooths and sharpens these fractures over millennia, sometimes creating uncannily geometric shapes. On Earth, similar formations exist in places like Utah's slot canyons, where nature carves passageways so straight they look handcrafted. So why does this particular crack look so much like a door? It's a classic case of perspective and scale. The image was taken from an angle that exaggerates the depth and symmetry of the fracture, making it appear like a recessed entryway. Side-by-side comparisons with human-made doors reveal just how tiny it really is, far too small for any hypothetical Martian to stroll through. But that hasn't stopped the speculation. Some point to the lintel above the opening, suggesting it's too perfectly horizontal to be random. Others note the floor inside, which seems unnaturally flat. Geologists counter with a simple experiment. Stare at any rocky hillside long enough, and your brain will start picking out patterns, windows, faces, even entire buildings. It's how we're wired, yet here's the twist: while the doorway itself is natural, the discussion it sparked raises bigger questions. If Mars did have ancient builders, what would their structures look like after billions of years of erosion? Could we even recognize them? The doorway debate isn't just about one odd rock. It's a crash course in how we search for meaning, and how Mars keeps testing the limits of our imagination. Perhaps the most intriguing part: this isn't the first artifact Curiosity has found. The rover's album includes a spoon dangling from a ledge, a pyramid no taller than a football, even a thigh bone that's just a weirdly shaped stone. Each time the cycle repeats: excitement, analysis, debunking. But in a way, that's the real magic. Mars doesn't need aliens to be fascinating. Its geology alone is strange enough to keep us guessing. And every time we think we've seen it all, the red planet throws another curveball, reminding us that reality can be just as wondrous as any sci-fi fantasy. One day, Opportunity was trundling across Mars as usual, photographing the same patch of terrain it had studied for weeks, when suddenly there it was. A rock that hadn't been there before. Not just any rock, but a pale, almost perfectly circular stone roughly the size of a jelly donut, its edges smooth and its surface strangely bright against the rusty soil. Scientists dubbed it Pinnacle Island, and its sudden appearance in January 2014 sent mission controllers into a frenzy. How does a rock just materialize on Mars? The most plausible explanation: Opportunity itself kicked it up. The rover's wheels likely dislodged a buried fragment as it turned, flipping the stone into view like a pancake. Spectral analysis supported this. The rock's composition matched other local bedrock, just with a startlingly clean, dust-free surface that had been shielded underground. But here's the twist: the rock wasn't just geologically interesting. When scientists scrutinized it, they found it was packed with sulfur, magnesium, and manganese elements that suggest prolonged exposure to water long ago. In other words, this accidental discovery turned out to be a tiny time capsule, preserving minerals that hinted at Mars' wetter past. Of course, not everyone bought the flipped rock theory. Online forums lit up with wilder ideas: meteorites, alien artifacts, even pranks by NASA staff. The rock's near-perfect shape fueled speculation, with some claiming it resembled a fungal growth or a manufactured disk. Never mind that wind erosion can sculpt surprisingly round stones over millennia, or that perspective in Rover images can distort proportions. The jelly donut became a Rorschach test for pareidolia, proving once again how easily human minds project meaning onto Martian geology. What's often overlooked, though, is how this serendipitous find underscored the unpredictability of exploration. After a decade on Mars, opportunity was still surprising us, still revealing secrets hidden just beneath the surface, literally. The rock's sudden appearance wasn't just a curiosity, it was a reminder that Mars keeps its mysteries buried, waiting for the right moment or the right rover wheel to uncover them. And who knows what else might be lying just out of sight, one lucky bump away from rewriting the story of the red planet. From a distance, they look almost like a forest, rows of dark, spindly shapes stretching across the Martian dunes, as if some hardy vegetation had taken root in the rusty soil. These are the so-called trees of Mars, a stunning optical illusion that first baffled scientists and captivated the public when images from NASA, a Mars reconnaissance orbiter, surfaced in the late 2000s. At first glance, it's hard not to see them as some form of life, their shadows stretching long and narrow like pine trees at sunset. But zoom in closer and the truth reveals itself: these aren't biological at all. They're avalanches of dark basaltic sand, cascading down the slopes of Martian dunes in patterns so eerily familiar that our brains can't help but misinterpret them. What's actually happening here is a masterclass in geology and light. During the Martian spring, the planet's polar dunes thawed just enough for pockets of carbon dioxide ice beneath the surface to sublimate, transforming directly from solid to gas. As this gas builds pressure, it erupts upward, sending plumes of dark sand spraying onto the brighter frost-covered dunes. The result: streaks that flow downhill like ink spilled on parchment, some stretching hundreds of feet. When photographed from orbit with the sun low on the horizon, these streaks cast long, narrow shadows that align in parallel rows. To human eyes conditioned by millions of years of pattern recognition, the effect is uncanny. A lifeless landscape suddenly seems to bristle with growth. This illusion is a perfect example of pareidolia, the same psychological quirk that makes us see faces in clouds or animals in rock formations. Our brains are wired to seek out familiar shapes, especially those tied to survival, like vegetation or shelter. On Mars, where the environment is so alien yet visually reminiscent of Earth's deserts, the line between reality and perception blurs effortlessly. Even seasoned scientists admit to doing a double take when first encountering these images. The trees appear most strikingly in the planet's northern polar regions, where dunes like those in Richardson Crater become canvases for this seasonal spectacle. But the real marvel isn't just the illusion, it's the dynamic processes behind it. These landslides are proof that Mars is far from static. The planet's thin atmosphere and freezing temperatures create conditions where carbon dioxide, not water, drives erosion in ways we'd never see on Earth. The trees aren't just frozen in place, they're part of an ongoing cycle. Each spring, new streaks form as frost retreats, while older ones fade under dust storms or shifting winds. It's a reminder that Mars, for all its stillness, is still shaping itself in subtle, surprising ways. Of course, not everyone was ready to accept the scientific explanation. The images sparked fervent debate, with some insisting the patterns were too orderly to be natural. Others proposed alternative theories, from microbial mats to fossilized root systems, ideas that, while creative, ignore the wealth of data showing these features are pure geology. Yet, even debunked, the trees hold value. They challenge us to question our assumptions, to recognize how easily our Earth-centric perspectives can color what we see on other worlds. In the end, the Martian forest is a testament to two things: the boundless creativity of natural processes and the human mind's relentless drive to find meaning. Mars didn't plant these trees, but in tricking us into seeing them, it taught us something profound about both the universe and ourselves, because sometimes the most alien landscapes hold mirrors to our own ways of seeing, reminding us that wonder and misunderstanding often walk hand in hand. Perched on the slopes of Mount Sharp, a solitary rock formation juts from the Martian landscape with such geometric precision that it seems almost sculpted by design. This is the so-called Mars Pyramid, a roughly 3-foot-tall structure photographed by the Curiosity rover in 2015 and instantly hailed by some as evidence of an ancient alien civilization. With its triangular facets and unnaturally straight edges, the formation looks eerily like the Great Pyramid of Giza in miniature, fueling theories that intelligent builders once walked the Red Planet. But as with so many Martian mysteries, the truth lies in the interplay between perception and geology. Geologists were quick to weigh in, pointing out that pyramid-like shapes aren't rare in nature. On Earth, wind and water carve similar formations in deserts from Egypt to Arizona, where sandstone butts take on angular profiles after millennia of erosion. The key lies in something called differential weathering, where harder rock layers erode slower than softer ones, leaving behind flat, beveled faces. On Mars, where windstorms blast terrain with abrasive dust at speeds over 60 miles per hour, such sculpting happens even faster. High-resolution 3D models of the pyramid reveal its structure isn't perfectly symmetrical at all. Subtle irregularities in its angles and base disprove the idea of artificial construction. Instead, it's likely a ventefactor rock polished into sharp planes by relentless sandblasting. Yet what makes this formation remarkable isn't just its shape, but its context. The pyramid sits amid a field of rubble where other rocks show identical weathering patterns, just less dramatically. Some appear partially worn, their edges still rounded, as if caught mid-transformation into geometric forms. This gradient of erosion offers a snapshot of geologic time, showing how wind can turn a nondescript boulder into a near-perfect pyramid given enough millennia. Even the rock's composition plays a role, likely a hardy volcanic basalt resistant to uniform weathering, allowing those crisp facets to endure while softer material flakes away. For those still unconvinced, consider scale. At just arm's length to Curiosity's cameras, the pyramid is barely larger than a toaster. Alien architects capable of interplanetary travel would hardly bother with such modest monuments. But the deeper lesson here isn't about debunking. It's about how easily human minds impose order on chaos. We're pattern-seeking creatures, conditioned by evolution to spot deliberate designs, even in random geology. Mars, with its alien yet eerily familiar landscapes, plays to this tendency masterfully. Perhaps the most fascinating twist, similar debates have played out before. When Viking landers imaged the Inca city ridges in the 70s, their grid-like patterns sparked theories of Martian ruins until orbital scans revealed them to be natural dunes hardened by lava. The pyramid is just the latest chapter in this ongoing dance between wonder and science, where every rock tells two stories, one written by the wind, the other by our imagination. And somewhere in that gap, Mars keeps its greatest mysteries alive. In the vast, wind-swept plains of Mars, where every rock tells a story of erosion and time, Curiosity rover once stumbled upon a formation that made even seasoned scientists pause. There, nestled in the dust like some relic of a lost era, was a rock that looked uncannily like a fossilized femur, the long bone of a thigh. With its smooth curves, tapered ends, and what appeared to be a joint-like bulge, it was easy to see why the internet erupted with theories of Martian dinosaurs or even ancient humanoids. But as with so many Martian mysteries, the truth lies in the artistry of natural forces, not extraterrestrial biology. What gives this rock its bone-like appearance? The answer lies in a process called aeolian abrasion, where relentless Martian winds act like a sculptor's tools, sanding down softer material while leaving harder protrusions intact. Over millennia, these winds can carve rocks into shapes that mimic organic structures, twisted spines, knobby joints, even what appear to be skeletal fragments. On Earth, we see similar illusions in places like Nevada's Valley of Fire, where sandstone erodes into formations that resemble petrified logs or animal bones. The Martian femur is just a particularly convincing example of this universal geological sleight of hand. But why haven't we found real fossils on Mars? The absence isn't for lack of trying. Fossilization requires very specific conditions: rapid burial to protect remains from scavengers and decay, mineral-rich water to seep into tissues, and stable geology to preserve them over eons. While Mars once had flowing water, its environment may have been too acidic or volatile for fossils to form, or too harsh to survive billions of years of radiation and erosion. That said, if microbial life ever existed there, our best hope lies in microscopic fossils trapped in sedimentary rock like Earth's stromatolites. Perseverance Rover is currently drilling into Jezero crater's ancient lake bed, searching for hints of such delicate traces. The femur rock also highlights a fascinating tension in how we explore other worlds. When Vikings landers imaged the face on Mars in the 70s, or when opportunity found its jelly donut, each discovery followed the same arc: initial wonder, scientific scrutiny, then often deflating explanations. Yet these moments aren't failures, they're masterclasses in how human perception works. Our brains evolved to spot patterns, especially those tied to life, in a survival mechanism called pareidolia. It's why we see faces in clouds or religious figures in toast. On Mars, where every landscape feels both alien and eerily familiar, this instinct goes into overdrive. Playfully, the femur rock has earthly cousins that fool even experts. The bone in New Mexico's Ghost Ranch, once thought to be a dinosaur relic, turned out to be a weathered log. Oregon's Blue Lake Rhino, a submerged rock formation, briefly convinced locals they'd found a Pleistocene fossil. These examples remind us that nature is the ultimate artist, capable of crafting illusions that challenge even trained eyes. So while the Martian femur isn't proof of ancient giants, it is proof of something equally profound: a planet that constantly toys with our expectations. Every strangely shaped rock is a reminder that Mars doesn't need aliens to captivate us. Its geology alone is strange enough to keep the wonder alive. And who knows, one day we might yet stumble upon a fossil that rewrites history. Until then, the femur stands as a monument to both our curiosity and the universe's knack for playful deception. It was just another routine panorama sent back by the Curiosity rover until sharp-eyed viewers spotted something unsettling. There, in the rocky foreground, stretched a long, thin shadow with what appeared to be arms and legs, as if some stick figure being had paused mid-stride to watch the robot roll by. The image, snapped in 2019, spread like wildfire online, with theories ranging from Martian wildlife to clandestine NASA cover-ups. But zoom in closer, and the figure dissolves into what it always was: a trick of light and perspective, where a jagged rock caught the sunset just right to cast a crudely humanoid silhouette. What makes this illusion so compelling isn't its plausibility after all. A 5-foot-tall being wouldn't last 5 minutes in Mars' brutal radiation and near vacuum, but the visceral reaction it triggers. Our brains are hardwired for hyperactive pattern recognition, an evolutionary quirk that once helped ancestors spot predators in dense foliage. Today, that same instinct makes us see faces in electrical outlets or religious figures in burnt toast. On Mars, where the landscape feels tantalizingly close to Earth's deserts yet remains utterly alien, this tendency goes into overdrive. The stick figure isn't just a shadow, it's a Rorschach test for our collective imagination. Scientists call this effect pareidolia, and Mars serves up textbook examples. The Happy Face crater near the South Pole grins up at orbiters with pit-shaped eyes. Boulder fields morph into crowds of watching statues when backlit by the low sun. Even the Viking landers' first images in the 70s spawned claims of carved, head-like rocks, later revealed to be ordinary vents. What's fascinating is how these illusions persist despite overwhelming evidence. The stick figure shadow, for instance, reappears in subsequent Rover images from different angles, clearly showing its true form, a mundane, irregular stone. Yet the myth endures because it taps into something deeper than logic, our hunger for connection in a cosmos that often feels indifferent. This phenomenon isn't unique to Mars. Earth's own history is littered with misinterpreted geology, from Arizona's Shoe Rock, a volcanic formation eerily resembling a sneaker, to Japan's Moai Stone, a natural feature mistaken for Easter Island artifacts. The difference: on our planet, we can walk up and touch these formations, dispelling the illusion instantly. Mars, by contrast, remains just out of reach, its landscapes mediated through rover cameras that flatten depth and amplify ambiguity. A two-dimensional image taken from one vantage point leaves vast room for projection, especially when that image comes from a world we've long fantasized about inhabiting. Perhaps the stick figure's greatest lesson is how it reflects our own expectations. Early astronomers like Percival Lowell famously mapped canals on Mars, convinced they were evidence of a dying civilization. Today, we project different visions: viral shadows, mysterious lights, even viral memes. Each generation sees Mars through the lens of its own anxieties and aspirations. The stick figure isn't a hoax or a discovery, it's a mirror, showing how desperately we search for familiarity in the unknown. And who knows, one day, when humans finally walk those rusty plains, they might chuckle at how their ancestors mistook wind-carved rocks for company. Until then, Mars will keep playing these visual tricks, reminding us that seeing isn't always believing. Somewhere on the rocky slopes of Mount Sharp, a tiny shape crouches in the Martian dust, its rounded back, pointed snout, and even what appears to be tiny ears frozen in perfect rodent-like detail. This is the infamous Mars rat, a small rock photographed by Curiosity in 2013 that instantly became the internet's favorite extraterrestrial mammal. At first glance, it's hard not to see a creature paused mid-scurry, perhaps a cosmic cousin to Earth's desert-dwelling kangaroo rats, but peer closer and the illusion unravels. The rat is barely 5 inches long, its features nothing more than shadows and texture playing tricks on the human eye. Yet for a brief moment, Mars seemed to host something undeniably alive, and that flicker of recognition reveals something profound about how we explore the unknown. What makes this particular rock so convincingly lifelike? The answer lies in 3 deceptive ingredients: shape, lighting, and psychology. First, wind erosion has sculpted the stone into a rough approximation of a rodent silhouette, rounded at one end, tapered at the other, with subtle undulations mimicking limbs. Second, the low-angle sunlight when the image was taken cast long, directional shadows that accentuated these curves, creating the illusion of depth where none exists. But the real magic happens in the third ingredient, pareidolia, our brain's compulsive habit of imposing familiar patterns, especially faces and animals, onto random shapes. It's the same quirk that makes us see dragons in clouds or the man in the moon. On Mars, where every landscape feels almost terrestrial, this tendency goes into overdrive. To understand just how common this is, look no further than Earth's own deserts. Arizona's Goblin Rock near Winslow resembles a crouching imp when backlit at dusk. Australia's Wave Rock appears to freeze a cresting ocean swell in stone. Even New Hampshire's Old Man of the Mountain, a granite profile so perfect it became a state symbol, was just a chance arrangement of ledges until erosion collapsed it in 2003. These formations share a key trait with the Mars rat. They're static, unchanging objects that only momentarily align with our expectations based on perspective and light. Shift your viewpoint by a few degrees or wait for the sun to move and the spell breaks. Yet the Mars rat endures as a cultural icon because it taps into a deeper hope that we might not be alone. When Vikings landers returned images in the 70s, some scientists genuinely expected to spot wildlife scurrying past the cameras. While we now know Mars' surface is inhospitable to complex life, that primal longing persists. The rat isn't just a geological oddity, it's a Rorschach test for our cosmic loneliness. Scientifically, the rock offers its own lessons. Close analysis reveals it's likely a ventifact, a stone polished by millennia of sand-blasting winds, with a composition matching other basaltic fragments in Gale Crater. Its ears are jagged protrusions where harder material resisted erosion. The tail, a trailing edge where softer rock wore away. But here's the twist: while the rat itself is ordinary, its discovery spot isn't. Curiosity found it near an area rich in clay minerals, a clue to Mars' watery past. Even in debunking one mystery, the rat points toward bigger questions about the planet's history. Perhaps the most fascinating footnote: the Mars rat has earthly twins. In Egypt's white desert, wind-carved chalk formations mimic everything from chickens to mushrooms. Utah's Goblin Valley teems with bulbous rocks that seem to gather in families. Each serves as a reminder that nature is the ultimate sculptor, capable of crafting uncanny imitations of life without any intent. So the next time you see a strangely shaped rock, whether on Mars or in your backyard, remember the rat. It's not proof of aliens, but it is proof of something equally wondrous. A universe so rich in complexity that even its accidents can stir our imagination. And who knows, one day we might find a fossil that does rewrite the story of life. Until then, Mars will keep gifting us these playful illusions, blurring the line between what we see and what we wish to see. Amid the rusty monotony of Mars' surface, a glint of something unexpected caught the Curiosity rover's lens in 2014. A rock so conspicuously out of place that it earned the nickname Lebanon for its uncanny resemblance to a metallic nugget. Unlike the dull, weathered stones around it, this object shone with an almost mirror-like sheen, its smooth surfaces reflecting sunlight with unnatural intensity. At roughly 2 feet wide, it stood out like a chrome-plated artifact dropped onto a desert of rust, instantly fueling speculation. Was this a scrap of alien machinery? A fragment of some long-lost Martian technology, or just another trick of geology? The truth, as always, lies in the details. Close-up analysis revealed Lebanon's secret. It's almost certainly a meteorite, a cosmic traveler that survived the plunge through Mars' thin atmosphere to embed itself in the soil. Spectroscopy data showed it's rich in iron and nickel hallmarks of metallic asteroids that have battered the inner solar system for billions of years. Its polished appearance, that's the result of eons of space weathering, where micrometeorite impacts and solar wind particles buff its surface to a high sheen. On Earth, we'd call this a shiny iron meteorite, and they're prized by collectors for their otherworldly gleam. But on Mars, where the atmosphere is too thin to burn up incoming space rocks efficiently, such specimens might be far more common than we realize. Yet Lebanon isn't alone, it's part of a trio. Nearby, Curiosity spotted 2 smaller metallic siblings dubbed Lebanon B and Lebanon C, all likely fragments of the same parent body that shattered on impact. Their proximity suggests a single meteorite that broke apart mid-air or upon hitting the ground, scattering debris across the site. And here's where it gets even more intriguing. These fragments aren't just lying atop the soil. Lebanon is partially buried, its base fused into the Martian crust, hinting that it's been there long enough for wind-blown dust to partially reclaim it. That means it could be thousands or even millions of years old, a silent witness to Mars' climatic shifts. But why does Lebanon look so different from other Martian meteorites found by rovers? Earlier discoveries like heat shield rock found by Opportunity in 2005 had a more pitted, corroded appearance, their surfaces dulled by oxidation. Lebanon's reflectivity suggests it's either younger, less time exposed to Mars' corrosive dust storms, or composed of purer metal resistant to weathering. Alternatively, it might have landed in a sheltered spot, shielded from sand-blasting winds that would otherwise scuff its shine. Either way, its presence raises fascinating questions. How many more of these metallic interlopers are hiding in plain sight, camouflaged by dust or overlooked in rover panoramas? And could their composition tell us something new about the asteroid belt they came from? Of course, there's always another possibility: volcanic origins. Mars' geological history includes eruptions that could have produced dense, metallic-looking rocks like iron-rich basalts or even rare nickel-bearing lavas. Some researchers point to terrestrial analogues like Iceland's gleaming obsidian or the metallic sheen of certain volcanic bombs. If Lebanon is volcanic, it would imply a far more complex geologic history for its location in Gale Crater, one that might include previously unknown magma compositions. What makes Lebanon truly special, though, isn't just its sparkle, it's the way it challenges our assumptions. On a planet where every new discovery seems to blur the line between the familiar and the alien, a shiny rock becomes more than a curiosity. It's a reminder that Mars isn't just a world of ancient rivers and dust storms, it's also a cosmic dumping ground, littered with fragments of asteroids that whisper tales of the wider solar system. And perhaps, if we're lucky, the next glint on the horizon will reveal something even more extraordinary. A meteorite forged not in the asteroid belt, but in the heart of a dying star, carrying secrets from beyond our own cosmic neighborhood. Until then, Lebanon remains a tiny beacon on the rusty plains, proof that sometimes the most ordinary things, like a rock falling from the sky, can shine brightest when least expected. Nestled among the chaotic rubble of Gale Crater lies a rock that looks like it was dropped by a forgetful astronaut, a bizarre, grid-patterned slab so perfectly geometric that it's been nicknamed the Martian Waffle. When Curiosity rover rolled up to this oddity in 2015, the internet lit up with theories of alien pavement, fossilized machinery, even cosmic breakfast leftovers. And honestly, at first glance, it's hard to blame the speculation. The rock's surface is crisscrossed with near-perpendicular ridges, creating a lattice so precise it could pass for a man-made grate or the imprint of some ancient honeycombed structure. But as with so many Martian mysteries, the reality is a masterclass in how nature can outdo even our wildest imaginations. The secret behind the Waffle rock isn't alien engineering. It's a phenomenon called boxwork fracturing, a type of erosion pattern seen in certain sedimentary rocks when harder mineral veins resist weathering while the surrounding softer material wears away. On Earth, you'd find strikingly similar formations in places like South Dakota's Badlands or Utah's Canyonlands, where sandstone fractures into geometric grids over millennia. The process begins deep underground, where mineral-rich fluids seep into cracks, depositing durable materials like quartz or calcite. Later, when wind and water strip away the softer rock around these hardened veins, the result is a raised, grid-like skeleton, nature's version of a waffle iron. What makes Mars' version so mesmerizing is the crispness of its pattern. Unlike Earth's boxwork, which often appears weathered or irregular, this rock's ridges are startlingly uniform, likely because Mars lacks the relentless rain and vegetation that blur such formations on our planet. Instead, the red planet's thin atmosphere and abrasive dust storms act like a precision etcher, sharpening each ridge over eons. Scientists suspect the Waffle rock's composition plays a role too, possibly a mix of sulfate minerals that hardened into a lattice before being exhumed by wind. Yet even with this explanation, there's an eerie dissonance when you stare at the images. The rock's symmetry feels almost too perfect, its angles too deliberate. That's where psychology kicks in. Humans are wired to spot manufactured patterns. It's why we see faces in random shapes or hear words in static. When faced with something as orderly as this grid, our brains scream design long before they consider geology. It's the same impulse that turned the face on Mars into a cultural icon or made the Mars rat go viral. The Waffle rock taps into our deep-seated need to find intention in randomness, even on another world. Interestingly, the rock also serves as a time capsule. Its fractures likely formed billions of years ago, when Mars was still geologically active and water may have flowed through its subsurface. The minerals that now form its ridges could hold clues about the planet's ancient chemistry, perhaps even hints of long-gone hydrothermal systems that once bubbled beneath Gale crater. In this way, the Waffle isn't just a curiosity. It's a puzzle piece in the larger mystery of Mars' wetter, warmer past. Of course, not every grid pattern on Mars has such a tidy explanation. Elsewhere on the planet, orbital images have captured sprawling, geometric landforms dubbed Inca City and the Honeycomb, their origins still debated. Some researchers argue these might be the remains of ancient lava flows or sand dunes cemented into stone, their patterns shaped by long-vanished winds or tides. Others propose more exotic processes, like the contraction of ice-rich soils or the collapse of underground caverns. The Waffle rock, small as it is, reminds us that Mars' surface is a palimpsest, layer upon layer of geologic history waiting to be decoded. So next time you pour syrup on a waffle, spare a thought for its cosmic counterpart. What looks like a breakfast accident is actually a testament to the universe's knack for repetition, turning the same geological scripts across worlds. Mars didn't need aliens to craft its waffle, just time, pressure, and the quiet patience of the wind. And who knows, maybe somewhere out there, another planet's rocks resemble pancakes. The cosmos has a sense of humor like that. Amid the dust and rocks of Gale crater, Curiosity rover's cameras once focused on something that seemed utterly out of place, a delicate, flower-like structure no larger than a coin, its petals fanning outward as if frozen mid-bloom. This wasn't some bizarre Martian flora, but a mineral formation so intricate it blurred the line between geology and art. Dubbed the Mars flower, this tiny masterpiece instantly captivated scientists and space enthusiasts alike, not because it hinted at life, but because it revealed just how alive Mars geology can be. So what created this mineral bloom? The leading theory points to diagenetic crystal growth, a process where minerals slowly precipitate from groundwater, forming intricate structures as they accumulate. On Earth, you'd see similar formations in caves as stalactites or in hot springs as terraces. But on Mars, the recipe was slightly different. Scientists believe the flower likely grew from sulfate or silica-rich fluids that once seeped through porous rock. As these mineral-laden waters evaporated or their chemistry shifted, microscopic crystals began to form layer by layer over thousands of years. The result: a cluster of radiating blades, their arrangement so precise they mimic organic growth. What's fascinating isn't just the flower's beauty, but what it says about Mars' underground past. These delicate structures couldn't have formed in harsh surface conditions. They needed stability, a protected environment where fluids could linger and minerals could crystallize undisturbed. That suggests the flower grew in a fracture or small cavity, shielded from the planet's punishing dust storms and temperature swings. In a way, it's a fossil not of life, but of ancient groundwater activity, capturing a moment when Mars' subsurface was still chemically active. But here's where it gets even more intriguing. The flower isn't alone. Nearby, Curiosity has spotted other peculiar formations, tiny, worm-like ridges nicknamed stick figures, and bulbous nodules that resemble coral. Together, they paint a picture of a dynamic wet past where groundwater didn't just exist but moved, carrying dissolved minerals into nooks and crannies, leaving behind these miniature sculptures as evidence. It's a stark contrast to Mars' barren surface today, a reminder that the planet was once geologically bustling, Of course, not everyone initially agreed on the flower's origins. Some researchers floated alternative ideas, like concretion, a process where minerals cement around a central nucleus, creating concentric layers. Others wondered if wind erosion could carve such delicate features, though that seems unlikely given their fragility. What settled the debate was the flower's composition. Spectrometer data showed it was rich in sulfates, minerals notorious for forming crystalline structures in watery environments. Case in point, Earth's own gypsum flowers, which sprout in deserts where groundwater seeps to the surface. Yet the Mars flower's real magic lies in how it challenges our perceptions. It's easy to dismiss Mars as a dead world, a static tableau of rocks and dust, but formations like this whisper otherwise. They hint at a planet that once breathed chemically, where unseen fluids dance through cracks, leaving behind traces too exquisite to ignore. And while it's not proof of life, it is proof of something equally profound. A world that was, and perhaps still is, capable of creating beauty in the most unexpected ways. So the next time you see a flower on Earth, remember its cosmic cousin on Mars, a reminder that even in stillness, the universe finds ways to surprise us. Near the Martian poles, the landscape takes on a surreal, almost mythical quality, a vast expanse of interlocking plates, each one ridged and textured like the armored hide of some slumbering beast. This is the dragon scales of Mars, a bizarre terrain first spotted by NASA, a Mars reconnaissance orbiter. Stretching for miles across the icy badlands, these overlapping plates look less like geology and more like the petrified remains of a colossal dragon's underbelly frozen in time. But behind this fantastical facade lies a real scientific puzzle. What forces could shape a landscape so unnervingly organic? One leading theory points to the interplay between ice and sediment, a slow-motion dance that unfolds over millennia. During Martian winters, carbon dioxide frost blankets the polar regions, seeping into the soil and expanding as it freezes. Come spring, this frost sublimates directly back into gas, creating pressure that buckles and cracks the surface. Over countless cycles, this push and pull could fracture the ground into polygonal plates, their edges curling upward like baked mud in a desert. Supporting this idea, similar though smaller formations appear on Earth in Arctic permafrost, where freeze-thaw cycles create patchworks of raised hummocks. But Mars takes the process to extremes, with some plates spanning hundreds of feet and exhibiting textures unlike anything terrestrial. Another possibility involves ancient glaciers. Some researchers suggest these scales might be relics of long-vanished ice sheets, their surfaces crumpling as they crept across the terrain. As the ice deformed under its own weight, it could have dragged underlying sediment into these distinctive ridges. Or perhaps wind played a role, the relentless Martian gales sandblasting softer material from between harder layers, leaving behind this armored appearance. The truth might even be a cocktail of all three processes, with ice, wind, and thermal cycles conspiring to sculpt something truly alien. What's especially striking is how these formations mirror mythological imagery. The plates aren't just rough, they're meticulously patterned with a reptilian symmetry that feels almost intentional. It's no wonder early observers dubbed them dragon scales. They're a perfect example of how Mars constantly blurs the line between science and folklore. But while the name is poetic, the implications are grounded in hard data. These textures could be frozen records of past climate shifts, each ridge a whisper of how Mars' polar ice has advanced and retreated over eons. And then there's the color. In enhanced images, the scales shimmer with hues of blue and white, their icy veneer glinting against the rust-colored plains. This isn't just artistic license, it's a clue to their composition. Spectral analysis suggests they're rich in water ice and certain sulfates, minerals known to form in the presence of liquid water. Could these dragon scales be hiding reservoirs of buried ice, remnants of a wetter Mars? If so, they're not just curiosities, they're potential treasure maps for future explorers, marking spots where humans might one day dig for water to drink or split into oxygen. Of course, not every scientist agrees on the details. Some argue the scale's uniformity hints at volcanic origins, where lava flows fractured as they cooled. Others propose they're the aftermath of massive dust storms, their winds sculpting the terrain into these eerie patterns. The debate underscores how much we still have to learn about Mars' polar mechanics. Every new orbiter pass or rover scan adds data, but the dragon scales guard their secrets fiercely. Perhaps the most tantalizing thought is this: if such landscapes existed on Earth, they'd be crawling with extremophiles microbes thriving in the cracks and crevices. On Mars, the scales might be sterile, but they're a reminder that nature's artistry knows no bounds. Whether carved by ice, wind, or some process we've yet to imagine, they stand as proof that even in the cosmos' harshest corners, beauty persists, not in spite of the forces that shape it, but because of them. And who knows, maybe one day, when humans finally walk those icy wastes, they'll run their gloves along those ridged plates and feel, just for a moment, like they've stepped into a legend. Mars plays tricks on the eyes and sometimes even on the cameras we send to study it. Take the so-called Mars ghost, an eerie apparition that appeared in a rover's shadow during one of its routine self-portraits. There, lurking just behind the robotic explorer, was a faint, human-like figure, tall, slim, almost spectral in its silhouette. For a brief moment, it seemed as though some phantom observer was standing on the red planet, watching our mechanical emissary from the shadows. The internet, of course, erupted with theories: Martians, time travelers, even interdimensional beings. But the truth, as it often is with these mysteries, is far simpler, yet no less fascinating. The ghost turned out to be nothing more than a trick of light, likely a lens flare or a dust speck catching the sun at just the right angle to cast an elongated, vaguely humanoid shape. These optical illusions aren't unique to Mars. Astronauts on the International Space Station have captured similar phantom-like streaks in their photos, caused by reflections or stray particles floating near the camera lens. Yet on Mars, where the landscape is so stark and the silence so absolute, our minds race to fill the void with meaning. A speck of dust becomes a specter, a shadow turns into a sentinel. Why does this keep happening? Part of it stems from Mars' profound isolation. Unlike Earth, where every horizon hums with life, birds in the sky, rustling grass, distant voices, Mars is a world of utter stillness. The wind whispers, but there are no trees to answer. The dust stirs, but no creatures scurry through it. That emptiness does something to us. It heightens our senses, primes our brains to detect patterns where none exist. Scientists call this agent detection bias. The evolutionary impulse to assume a shadow in the bushes is a predator rather than a trick of the light. On Mars, where every rock and ripple feels just familiar enough to be uncanny, that bias goes into overdrive. But there's another layer to this. The ghost isn't just a misinterpretation. It's a mirror, reflecting our own longing for connection in a cosmos that often feels indifferent. Humans have always projected themselves onto the unknown, from sailors seeing mermaids in the waves to explorers mapping fantastical civilizations onto uncharted lands. Mars, as the most Earth-like world in our solar system, invites that projection more than any other. We want to find something or someone there, even if it's just a trick of the light. And let's be honest, Mars' aesthetic doesn't help. The rusty hues, the low-gravity elongating shadows, the way dust hazes the air like an old photograph, it all conspires to create an atmosphere ripe for the eerie. Think of the rover's shadow stretching across the sand, a lonely sentinel against an alien sky. It's a scene straight out of a sci-fi novel, where every frame feels like it could hide a revelation. No wonder we keep seeing ghosts. What's truly remarkable, though, isn't the illusion itself. It's how these moments reveal the human side of exploration. Scientists may roll their eyes at yet another Martian specter headline, but even the most disciplined minds can't help but feel a flicker of wonder when faced with the unknown. That tension between skepticism and awe, between data and imagination, is what makes Mars so endlessly compelling. So the next time you see a ghost in a rover's shadow, remember, it's not about what's actually there. It's about what Mars makes us feel, a world so close yet so alien that it holds up a mirror to our deepest hopes, fears, and the stories we tell ourselves about the universe. And in that sense, maybe the ghosts are real after all, not in the dust, but in us. Rolling across the bleak plains of Meridiani Planum, the Opportunity rover encountered something utterly unexpected. A rock so perfectly round it could have been plucked from a cosmic game of billiards. Nicknamed the Mars Cannonball, this uncanny sphere seemed almost out of place amidst the jagged rubble, its smooth contours gleaming under the Martian sun. At roughly the size of a grapefruit, it was far from the largest oddity on Mars, but its symmetry was arresting. How does nature sculpt something so geometrically flawless on a world without tools or hands? The answer lies in a process so universal it's left its mark on Earth too. Just ask Utah's Moqui marbles. These Martian orbs share an eerie kinship with Earth's own natural spheres. In the deserts of the American Southwest, Moqui marbles litter the sandstone like iron-washed pearls, forged over millennia when groundwater rich in iron oxide percolated through porous rock. As the water evaporated or chemical conditions shifted, the iron precipitated out layer by microscopic layer, cementing grains of sand into near-perfect spheres. The same basic recipe, mineral-rich fluids, patience, and the unrelenting forces of erosion likely shaped the Mars Cannonball. On the red planet, where liquid water once flowed, similar iron-rich solutions could have seeped through sediments, gradually building concentric layers until only the most resilient cores remained, polished smooth by eons of windblown sand. Yet Mars adds its own twists to this geologic tale. The cannonball's surface shows subtle pitting and texture, clues that it endured a harsher baptism than its earthly cousins. Without an atmosphere to shield it, the sphere was likely sandblasted by global dust storms, micrometeorite impacts, and temperature swings that would shatter less sturdy stones. That it survived intact speaks to its unusual density, possibly a hematite-rich composition like the blueberries found nearby. Even its isolation is telling. On Earth, Moqui marbles often cluster like grapes, still half embedded in their parent rock. The cannonball, by contrast, sits alone, suggesting it rolled free from some ancient outcrop long since worn away, a lone survivor of a vanished landscape. What's most fascinating isn't just how these spheres form, but what they reveal about their worlds. On Earth, Moqui marbles are time capsules, hinting at climates and water tables from epochs past. The cannonball, too, is a silent witness, perhaps to a time when Mars' groundwater was still fluid enough to ferry minerals, or when its winds carried enough force to sculpt stone into art. It's a reminder that perfection in nature isn't about intent but equilibrium, the exact balance of chemistry, erosion, and time needed to turn chaos into geometry. And then there's the sheer improbability of the find. Opportunity stumbled upon the cannonball by chance, a single spherical oddity in a wasteland of fractures and fragments. How many more might be out there, hidden beneath dust or perched on some unexplored slope? Each one could hold a slightly different story, a variation in composition or texture that adds another piece to Mars' geological jigsaw. So while the cannonball isn't an alien artifact, it's no less extraordinary. It's proof that the universe has an eye for elegance, crafting symmetry even in the most inhospitable corners. And the next time you see a near-perfect sphere, whether in a desert on Earth or a rover's image from Mars, remember, it's not a stroke of luck, but the slow, silent mathematics of nature at work. Among the countless craters scouring Mars' surface, one stands out not for its size or depth, but its bizarre shape, a formation so peculiar it's earned the nickname Mars Tadpole. Unlike the typical bowl-shaped impact scars, this unusual depression stretches across the landscape with a rounded head and a long, winding tail, resembling a cosmic amphibian frozen mid-swim. First spotted in orbital imagery, the tadpole crater immediately challenged conventional explanations. Most craters are circular, forged in an instant by meteorite impacts. But this looked sculpted, as if some unseen force had patiently carved its curves over millennia. The leading theories all revolve around one thing: flow. Liquid or gas, ancient or ongoing, something once moved across this terrain with enough force to gouge that winding tail. Some scientists point to water, suggesting the tadpole could be a relic of catastrophic flooding. Imagine a torrential burst from underground aquifers or melting glaciers, channeling through fractures in the bedrock with such intensity that it scoured this bizarre path before evaporating into Mars' thin air. Supporting this, the tail's edges show layered deposits reminiscent of sedimentary patterns left by Earth's flash floods. Even the crater's head could be a collapse feature, where raging water undermined the surface until it caved in. But water isn't the only artist at work here. Another camp argues for wind, specifically long-term abrasion by dust-laden storms. Mars' atmosphere may be thin, but its winds can reach hurricane speeds, carrying abrasive particles that sandblast the landscape over eons. The tadpole's tail aligns with regional wind patterns, suggesting it might be an elongated ventifact, a groove slowly etched by persistent gusts. The head, then, could mark a weakness in the bedrock where wind found purchase, grinding deeper while leaving the tail as a trailing scar. Then there's the wild card, lava. Some researchers propose that the tadpole's shape mirrors features in volcanic terrains, where molten rock once oozed across the surface, melting ice-rich soil and creating collapsed channels. The tail might trace the path of an ancient lava tube, its roof long since collapsed. If true, the tadpole could be a rare hybrid, part impact crater, part volcanic artifact, a testament to Mars' geologically violent past. What makes the tadpole truly confounding, though, is how it resists any single explanation. Its tail twists in ways that don't neatly match wind models. Its layered deposits seem too delicate for catastrophic floods, and its location far from major volcanic provinces makes the lava theory a stretch. This isn't just a crater, it's a palimpsest of overlapping forces, a terrain where water, wind, and perhaps even ice each left their mark. Zooming out reveals another layer to the mystery. The tadpole isn't alone. Nearby, similar elongated depressions dot the landscape, though none as perfectly formed. This clustering suggests regional conditions favored such features, perhaps a unique blend of weak bedrock and persistent erosion. Or maybe something more exotic, like the sublimation of buried ice sheets, leaving behind meandering hollows as the gas escaped. For now, the tadpole remains a tantalizing what-if. Every new orbiter pass adds data, but the answer might require boots on the ground, a geologist's hammer chipping at those layered walls, searching for the mineral fingerprints of water or the glassy residues of lava. Until then, it's a reminder that Mars scars aren't just collisions, they're stories, and some stories, like the tadpoles, are still being written. If you thought spiders were an Earth-bound terror, wait until you see their Martian cousins, not actual arachnids, but sprawling, dendritic formations etched into the polar ice that look as if some cosmic arachnid dragged its legs across the frozen landscape. This is the areniform terrain, a hauntingly beautiful network of dark, branching channels nicknamed Mars spiders for their uncanny resemblance to eight-legged creatures caught in mid-crawl. Discovered in the early 2000s by orbiting spacecraft, these patterns sprawl across Mars' southern polar region, some stretching over half a mile wide, their tendrils radiating outward like cracks in a shattered mirror. But unlike real spiders, these aren't living things, they're scars left by a process as alien as the landscape itself, the explosive escape of carbon dioxide gas. Here's how it works. During Martian winters, temperatures at the poles plummet so low that CO2 from the atmosphere freezes directly onto the surface, building layers of dry ice thicker than a human is tall. Come spring, sunlight penetrates this translucent ice, heating the darker soil beneath. That warmth triggers a surreal transformation. The buried CO2 ice doesn't melt but sublimates, turning straight from solid to gas. Trapped beneath the ice layer, this gas builds pressure until it finally ruptures the surface in violent jets, blasting dust and debris into the thin air. Over centuries, these eruptions carve the same paths again and again, etching those spider-like grooves into the ice as the dark material falls back and accumulates. But here's the catch. While the CO2 hypothesis is widely accepted, the details remain maddeningly fuzzy. Why do some spiders have dozens of thin, feathery tendrils while others look like blunt, stubby claws? Why do they cluster in some areas but avoid others entirely? Even the timing is odd. Some formations seem to darken and fade with the seasons, as if actively breathing, while others persist year-round like permanent tattoos on the ice. Some scientists argue wind plays a hidden role, shaping the erupting gas plumes into those intricate branches. Others point to variations in ice thickness or soil composition, suggesting the spider's forms are dictated by what lies beneath. Then there's the wild card. Could residual water ice be involved, altering the mechanics of sublimation in ways we haven't yet modeled? Every new orbiter pass adds data, but Mars refuses to surrender the full story. What makes these formations truly mesmerizing is how they blur the line between geology and performance art. In high-resolution images, the spiders look almost purposeful, their patterns too elegant to be accidental. Yet they're a reminder of how different Mars physics really are. On Earth, such landscapes would demand liquid water or wind. On Mars, they're sculpted by a substance we barely think of as an agent of change: carbon dioxide, the same gas we exhale with every breath. And then there's the existential question these spiders pose. Could similar processes be at work elsewhere in the solar system? Jupiter's moon Europa or Saturn's Enceladus have ice-shelled oceans where gases might fracture their surfaces in eerily familiar ways. The spiders, then, aren't just a Martian curiosity. They could be a template for understanding icy worlds far beyond our own. So the next time you see a spider's web glistening with dew, remember its cosmic counterparts on Mars, where the ice itself breathes and the shadows of invisible forces creep across the poles, waiting to be decoded. Out in the barren expanse of Mars' Gale crater, two rocks lean toward each other like star-crossed lovers frozen mid-embrace. Dubbed the kissing rocks by Rover drivers, their uncanny symmetry, smooth curves almost meeting at a single point, creates an illusion so striking it feels intentional. But this romantic tableau wasn't carved by alien hands. It's the work of an artist far more patient and relentless: the Martian wind. Wind erosion on Mars operates like a cosmic sandblaster, wielding dust particles as its chisel. Over millennia, these airborne abrasives scour softer rock layers while leaving harder protrusions intact, sculpting formations that flirt with familiarity. The kissing rocks likely started as part of a larger outcrop, their silica-rich cores resisting the wind's touch as surrounding material weathered away. What's left is a snapshot of erosion's artistry, a duet of geology and time where every curve whispers of forces that shape not just these rocks but entire landscapes. Earth offers its own gallery of wind-carved oddities. In Arizona's Coyote Buttes, the wave dazzles with undulating sandstone ribbons shaped by crosswinds over 190 million years. Egypt's white desert sprouts chalk spires so delicate they seem to defy gravity, their contours mirroring the very dunes that once buried them. Even the Moeraki boulders of New Zealand, near-perfect spheres scattered along a coastline, show how uniform erosion can birth near-mathematical precision. Yet Mars takes this process further. With an atmosphere just 1% as dense as Earth's, its winds lack brute force but compensate with persistence. A single dust storm here can last weeks, sandblasting at a microscopic scale but never stopping. The kissing rocks, then, are more than a curiosity, they're a lesson in patience. Where Earth's winds might carve a feature in millennia, Mars spends eons polishing its masterpieces grain by grain. What makes these formations truly mesmerizing is how they challenge our sense of scale. From orbit, the kissing rocks are just two specks in a crater. Through curiosity's lens, they become monuments. It's a reminder that Mars' mysteries aren't always grand canyons or towering volcanoes. Sometimes they're small, silent, and waiting for the right light to tell their story. So the next time you see wind-sculpted stones on Earth, remember their Martian cousins, proof that even in emptiness, the universe finds ways to connect. In the vast, undulating sea of Martian dunes, one formation stands out with a design so uncanny it seems pulled straight from science fiction. A massive delta-shaped dune that mirrors the iconic Starfleet insignia from Star Trek. Discovered by NASA Mars Reconnaissance Orbiter, this chevron of sand stretches across the rugged terrain like a deliberate insignia, its sharp angles and symmetrical arms defying the chaotic randomness of wind-sculpted landscapes. It's the kind of cosmic coincidence that makes you wonder, did Mars just wink at Star Trek fans across the solar system? The science behind this formation is just as fascinating as the pop culture serendipity. The dune's distinctive arrowhead shape isn't the work of interstellar Starfleet engineers, it's the handiwork of persistent, directional winds. On Mars, where the atmosphere is thin but the gusts are relentless, sand dunes often morph into elongated crescents called barchans. But this particular dune sits in a rare sweet spot where wind currents collide and rebound off nearby topography, sculpting the sand into that perfect angular wedge. The arms of the chevron point downwind, tracing the invisible flow of air like a compass needle. Over centuries, the same winds that carved this pattern will eventually erase it, making the Starfleet dune a fleeting masterpiece of planetary weather. Of course, the fun lies in the absurdity of the resemblance. The delta symbol, a core emblem of Star Trek's United Federation of Planets, represents exploration, unity, and the spirit of discovery. To find its mirror on Mars, of all places, feels like the universe offering a playful nod to humanity's dreams of venturing beyond Earth. Even NASA couldn't resist the joke, officially dubbing it the Starfleet Dune in a tongue-in-cheek press release. The timing only heightened the synchronicity. The discovery coincided with the 50th anniversary of Star Trek, as if Mars itself had RSVP'd to the celebration. But beyond the whimsy, the dune holds real scientific value. Its precise geometry offers clues about wind patterns that might otherwise be invisible. By studying its shape and movement, researchers can backtrack the forces that shaped it, like forensic scientists reading a crime scene written in sand. Similar dunes on Earth, like Namibia's wind-raked Sossusvlei, help calibrate these models, proving that even the most otherworldly landscapes obey universal rules of physics. Yet the Starfleet dune also raises a tantalizing question. How many other familiar shapes lie hidden in alien terrains? Mars has already given us waffle rocks, dragon scales, and even a flower-like mineral bloom. Each feels like a deliberate shout into the void, a whisper of recognition in a universe that so often feels indifferent. The dune isn't just a quirk of erosion. It's a reminder that exploration, whether through a rover's lenses or a starship's viewscreen, is as much about finding meaning as it is about collecting data. So the next time you gaze up at the night sky, remember, somewhere on Mars, a windswept patch of sand is silently saluting the dreamers, the trekkers, and everyone who's ever looked at the stars and imagined what might be waiting. The cosmos has a sense of humor, and sometimes it wears a very familiar badge. High on the dusty slopes of Mars Arcia Mons volcano, a gaping void punctures the surface like a sinkhole to another world. This is the Mars Hole, an enigmatic pit roughly the size of a football field, its Inkai depth swallowing sunlight whole. First spotted by NASA, a high-rise orbiter in 2017, the feature defies easy explanation. Unlike typical impact craters with raised rims and debris fields, this hole is sheer-walled and eerily circular, as if bored into the rock by some colossal drill. Peer into its shadowy throat and you'll see nothing but blackness, no floor, no rubble, just an abyss that seems to drop forever. The leading theory. A collapsed lava tube. Mars volcanic giants like Arsia Mons were once spewing rivers of molten rock, leaving behind hollow tunnels as their surface flows cooled and solidified. Over time, sections of these subterranean passages could have caved in, creating skylights like this one. Earth offers parallels. Hawaii's Kazumura Cave, the longest lava tube on our planet, has similar pit entrances where its roof gave way. But Mars' lower gravity and lack of tectonic activity might allow these tubes to grow far larger. Some estimates suggest they could stretch for dozens of miles, with ceilings high enough to dwarf Manhattan skyscrapers. That's where the speculation gets thrilling. Such caverns, shielded from Mars' punishing radiation and temperature swings, could be the closest thing the planet has to a hospitable environment. Astrobiologists salivate at the thought. If microbial life ever gained a foothold on Mars, these subterranean labyrinths might have offered refuge as the surface grew inhospitable. Underground, lingering water ice could have pooled, geothermal heat might have persisted, and chemical reactions could still be brewing. It's not just about past life. Some researchers argue these tubes might even harbor extremophiles today, clinging to existence in damp, dark niches. But lava tubes aren't the only possibility. Alternative explanations include pit craters, formed when magma reservoirs drain and the ground above collapses inward. These lack the lava flows of traditional volcanoes but create similar voids. Then there's the wild card, karst terrain, where acidic water dissolves subsurface rock, creating sinkholes like Earth cenotes in Mexico. If Mars once had acidic groundwater, could it have carved such features? The debate rages because each scenario carries different implications. Lava tubes suggest geologic drama frozen in time. Karst formations whisper of ancient groundwater networks. What makes this hole particularly tantalizing is what we can't see. High-rise camera lacks the angle to illuminate the shaft's bottom, leaving its true depth a mystery. Is it a shallow depression or a gateway to vast underground chambers? Radar data hints at void spaces beneath nearby terrain, but without a rover or, better yet, a drone to scout its depths, we're left guessing. That hasn't stopped mission planners from dreaming. Future human explorers might use such pits as natural shelters, their rocky roofs blocking cosmic rays while providing easy access to subsurface ice. In the grand tapestry of Martian mysteries, this hole is more than a geological oddity. It's a symbol of how much we still don't know about the planet's underworld, a realm that could hold answers to its watery past, its potential for life, and even the feasibility of human colonization. Every shadow in that abyss is a question mark, every theory a thread leading deeper into the unknown. One thing's certain, Mars keeps its deepest secrets hidden in plain sight, waiting for the day we're bold enough to descend into the dark. Stretching across the rust-colored plains of Mars, a series of perfectly parallel ridges cuts through the landscape like grooves on a vinyl record. A formation so strikingly uniform that early observers dubbed it the Mars barcode. From orbit, these near-identical stripes seem almost machined, their rhythmic precision defying the chaotic forces that shape most planetary terrain. But zoom in closer and the truth reveals itself. This isn't some alien QR code or the remnants of a long-lost civilization. It's nature's artistry at its most mathematical, a masterpiece sculpted by the patient hand of Martian wind. These linear dunes, known technically as longitudinal dunes, form when winds blow consistently from two opposing directions, allowing sand to accumulate in long, snake-like ribbons rather than the crescent-shaped barchans common on Earth. Imagine two children dragging their fingers through wet sand in opposite directions. The resulting ridges would mirror the Mars barcode's eerie symmetry. On the red planet, where global dust storms can rage for months and the thin atmosphere magnifies even gentle breezes into erosive forces, these conditions are the rule rather than the exception. The result, dunes that stretch for miles with barely a centimeter of deviation in their spacing, their crests standing like frozen waves in an ocean of dust. Contrast this with Earth's Martian dunes, those iconic crescent-shaped mounds found in deserts from the Sahara to Namibia. Martians form under one-directional winds, their horns pointing downwind like the tips of a bow tie. They're nomadic by nature, creeping across landscapes grain by grain. Mars' longitudinal dunes, by comparison, are more like anchored sculptures, their forms locked in place by the planet's unique atmospheric dance. While Earth's winds shift with seasons and weather systems, Mars' global circulation patterns create staggeringly consistent conditions, allowing these linear dunes to refine their precision over millennia. The scale of the Mars barcode is what truly stuns. Some of these dune fields span hundreds of kilometers, their patterns visible from space like the grooves of a cosmic record. Scientists have mapped similar formations in regions like Proctor Crater and Hellespontus Montes, each one a testament to the planet's wind-driven personality. Spectral analysis adds another layer. Unlike Earth's silica-rich dunes, Mars versions often contain volcanic basalt grains, their dark tones stark against the ochre plains. This composition affects their movement. Basalt's density means these dunes migrate far slower than their earthly counterparts, inching along at paces measured in decades rather than years. Yet the barcode isn't just a geological oddity, it's a Rosetta Stone for understanding Martian climate. The dune's orientation acts as a wind vane frozen in time, revealing ancient atmospheric currents that might have shaped the planet's weather for eons. Some researchers even speculate that subtle variations in dune spacing could encode clues about past climatic shifts, like pages in a dusty history book. And here's the kicker, these same processes might be unfolding right now on Saturn's moon Titan, where radar images show eerily similar linear dunes, proof that the universe loves repeating its greatest hits. What's most humbling, though, is how easily these natural wonders trick the human eye. The same pattern-seeking instincts that once saw canals on Mars now conjure barcodes, a reminder that reality often outstrips imagination. The next time you scan a grocery item, remember, somewhere across the void, Mars has been printing its own cosmic labels for billions of years, no laser required. Rising from the Martian plains like an ancient sentinel, the Mars Waffle cone stands as one of the most peculiar geological formations ever photographed on the red planet. Captured by NASA Mars Reconnaissance Orbiter, this bizarre feature resembles a perfectly symmetrical pastry, a near-identical twin to the textured cones you'd find at an ice cream shop. But don't let its whimsical nickname fool you. This isn't some intergalactic dessert. It's likely a window into Mars' fiery past, possibly the remnant of a volcanic vent or mud volcano that once belched heat and gases onto the surface. The cone's intricate structure is what makes it so fascinating. Its fluted sides, ribbed with precise ridges, spiral upward to a central summit, creating a geometric precision that seems almost manufactured. On Earth, similar formations appear in volcanic regions like Iceland's mud pots or Hawaii's lava domes, where viscous magma or boiling sediment hardens into conical shapes. But Mars adds extraterrestrial twists. Lower gravity means ejected material could have formed taller, more delicate structures, while the planet's thin atmosphere might have allowed gases to escape differently, sculpting unique textures. Yet the Waffle cone isn't just a volcanic look-alike. Some researchers propose it could be a pingo, an icy mound formed when underground water freezes and expands, thrusting the soil upward. Earth's Arctic tundras host these frost heaves, but Martian versions, if confirmed, would hint at vast buried ice reserves. Others suggest it might be a rootless cone, created when lava flows over ice-rich ground, triggering steam explosions that blast circular pits and ridges into the rock. Each theory carries weight, but without boots or rover wheels on the ground, the cone's origin remains deliciously unresolved. What makes this mystery so compelling isn't just the unanswered questions, but what the waffle cone represents. A reminder that Mars, for all its stillness today, was once a world of fire and upheaval. Every ridge on its surface whispers of forces that shaped not just this feature, but perhaps the entire planet's destiny. And until we can sample its layers or peer beneath its base, the cone will keep its secrets one tantalizing waffle at a time. Perched on the edge of a Martian outcrop, a slender rock formation juts into the thin air like a forgotten piece of cutlery, the so-called Mars floating spoon. When Curiosity rover beamed back images of this gravity-defying oddity in 2015, the internet couldn't resist the absurdity. Here was a stone with a straight, elongated handle and a rounded bowl at the end, seemingly suspended mid-air without support. It looked less like geology and more like some cosmic prankster had left their lunchware on the red planet. But before you imagine Martian chefs preparing extraterrestrial feasts, let's dissect how nature carved this uncanny utensil. The secret lies in differential erosion, a patient process where wind and dust act like invisible sculptors, picking away at softer rock layers while leaving harder material intact. The spoon's handle is likely a resilient vein of volcanic basalt or other erosion-resistant mineral, while the surrounding crumbly sandstone has slowly worn away beneath it. Over millennia, this created a cantilever effect where the tougher stone protrudes like a diving board over emptiness. Earth offers its own versions of this phenomenon. Utah's hanging rock or Australia's wave rock both showcase how wind and water can leave improbable overhangs. But Mars, with its low gravity and relentless dust storms, takes the concept further, allowing these fragile structures to persist longer than they ever could on our planet. What makes the spoon especially mesmerizing is its illusion of weightlessness. The angle of Curiosity's photograph hides the connecting base, making the rock appear to levitate. This trick of perspective isn't unique. Earth's balanced rock in Colorado or the Karakahua leaning wall in Arizona pull similar visual stunts. Yet Mars' stark lighting and lack of atmospheric haze amplify the effect, turning every shadow into a dramatic flourish. The spoon isn't just a rock, it's a masterclass in how light and viewpoint can transform geology into optical poetry. Of course, no cosmic quirk escapes speculation. Some enthusiasts insisted the spoon was too perfectly shaped to be natural, suggesting everything from alien artifacts to debris from a rover's lunch break. Others humorously proposed an entire lost Martian cutlery set, with forks and knives waiting to be discovered. Scientists, meanwhile, saw a valuable lesson in erosion dynamics. The spoon's delicate balance suggests it's a fleeting feature. One strong gust or micrometeorite impact could send it tumbling, a reminder that even seemingly eternal landscapes are in constant flux. The real marvel here isn't the spoon itself, but what it represents, a universe endlessly inventive in its artistry. Whether carving waffle rocks, dragon scales, or floating cutlery, Mars proves that nature doesn't need intelligence to create the illusion of design. It just needs time, the right conditions, and a little cosmic whimsy. So next time you set the table, spare a thought for that lonely spoon millions of miles away, proof that even in the void, the universe has a flair for the dramatic. Amid the endless rust-colored wastes of Gale Crater, Curiosity rover stumbled upon a rock that seemed to defy the ordinary, a perfect donut-shaped oddity nicknamed the Mars Cosmic Cheerio. This wasn't just another pebble in the Martian dust, it was a near-flawless ring, its hollow center staring like an eye into the void. At roughly the size of a car tire, the formation stood out with an almost comical precision, as if someone had dropped a breakfast cereal from orbit. But behind its whimsical appearance lies a serious geological puzzle. How does nature sculpt something so geometrically pristine on a world without hands or tools? The answer likely lies in the relentless artistry of wind erosion. Mars' thin but ferocious winds act like celestial sandblasters, carving softer rock layers while leaving harder material intact. The Cheerio's shape suggests it might be a ventifact, a stone polished by millennia of abrasive dust storms. On Earth, similar formations appear in deserts like Libya's Sahara, where winds sculpt rocks into eerie, mushroom-like pedestals. But Mars' lower gravity and lack of moisture allow for even more delicate structures to endure. The ring's uniformity hints that it was once embedded in a larger outcrop, its center hollowed out as surrounding material weathered away, leaving only the most erosion-resistant rim behind. Yet there's another tantalizing possibility. The Cheerio could be a meteorite remnant. Mars, with its thin atmosphere, is pockmarked with space debris that survives the plunge to the surface. Iron-nickel meteorites, in particular, often fracture into angular or ring-like shapes upon impact. Spectral data from Curiosity's instruments could settle the debate. If the rock shows high metal content, it might be a cosmic traveler rather than a homegrown curiosity. Either way, its presence speaks to Mars' role as a museum of collisions, where every odd shape might be a relic from the asteroid belt. What makes the Cheerio especially mesmerizing is its isolation. Unlike Earth's ring-shaped rocks, which often cluster in groups like Arizona's fairy circles, this one sits alone, a solitary hoop on the Martian stage. Its stark backdrop of dust and rubble amplifies the surrealism, turning a simple geological feature into a sculpture worthy of a gallery. And there's a deeper lesson here. In a landscape where randomness reigns, even the most orderly forms emerge from chaos given enough time and the right conditions. The Cheerio isn't just a rock, it's a testament to the universe's quiet obsession with repetition. From Saturn's rings to the molecular structure of benzene, circles recur across scales, a geometric motif woven into the fabric of reality. On Mars, where the rules are the same but the ingredients differ, nature finds new ways to etch its familiar patterns. So the next time you pour a bowl of cereal, remember its cosmic counterpart on the red planet, proof that even in the void, the universe loves a good loop. Mars does more than challenge our science, it plays tricks on our minds. Take the so-called Mars mermaid, a shadowy figure that seemed to lounge across the rocks in a 2016 Curiosity rover image. With a rounded head, a sinuous torso, and even what looked like a tapered tail, the formation sparked instant myth-making. Was this proof of Martian sirens, some relic of a lost aquatic civilization from the planet's wetter past? The truth, as always, is both simpler and stranger. The mermaid was just a wind-sculpted boulder, its silhouette stretched and distorted by the low-angle Martian sun, a mirage of geology and light. But why does this keep happening? Why do we see mermaids in shadows, faces in cliffs, and spoons in stone? The answer lies in a quirk of human cognition called pareidolia, the brain's tendency to impose familiar patterns on random shapes. On Earth, this instinct helps us spot predators in dense foliage or recognize friends in crowded rooms. On Mars, where the landscapes are just alien enough to feel uncanny, it conjures mermaids from rubble. The phenomenon isn't new. Sailors once mistook manatees for mythic creatures. Explorers projected cities onto canyon walls. Mars, with its eerie stillness, magnifies this impulse. Without birds, trees, or movement to ground our perception, every shadow becomes a story waiting to be told. The mermaid rock itself offers clues to its origin. Wind erosion on Mars favors angular, jagged formations, but occasional outliers emerge, stones with curves softened by millennia of abrasive gusts. Curiosity's cameras caught this one at twilight, when long shadows exaggerated its contours. Rotate the image slightly or change the lighting and the illusion shatters. It's a reminder that Mars' most viral mysteries often hinge on perspective. The same rock photographed at noon would barely warrant a second glance, yet the mermaid's legacy endures because it taps into deeper narratives. Humans have always projected myths onto the unknown, from constellations to storm gods. Mars, as the most Earth-like world in our solar system, inherits this role. Its dry riverbeds whisper of lost oceans, so why not mermaids? The irony is rich. A planet named for the god of war now hosts imagined nymphs. This duality, Mars as both a scientific frontier and a canvas for folklore, reveals how exploration is as much about imagination as data. Scientific rigor, of course, demystifies the mermaid. Spectrometers see minerals, not myths. Rovers measure regolith, not legends. But dismissing the phenomenon outright misses the point. These illusions are cultural artifacts showing how we process the unfamiliar. When Vikings landers revealed a barren world in the 70s, public interest waned. Today, viral discoveries like the mermaid reignite wonder, bridging the gap between hard science and collective imagination. Perhaps the real magic lies in the tension between these worlds. Mars doesn't need mermaids to fascinate. Its real geology, from dragon-scaled poles to waffle rocks, is fantastical enough. Yet these fleeting illusions serve a purpose. They remind us that exploration isn't just about solving mysteries, but savoring them. So the next time you see a shadow on Mars that looks like a face, a hand, or some mythical beast, enjoy the moment. The universe is vast, and sometimes it winks back. There's a moment in exploration when the universe seems to wink back at you, and for the team overseeing the Curiosity rover, that moment came when a routine snapshot revealed something spine-tingling, a shadow stretching across the Martian soil, its outline uncannily humanoid, as if some silent sentinel stood just beyond the frame. Dubbed the Mars Guardian, this elongated figure sparked instant fascination. With what looked like a head, shoulders, and even the suggestion of outstretched arms, the silhouette seemed too deliberate to dismiss as mere coincidence. But as with so many Martian mysteries, the truth is a dance between perception and physics, a reminder that Mars doesn't just challenge our tools, it plays tricks on our minds. The Guardian's anatomy breaks down under scrutiny. That head is likely a jagged rock catching the late afternoon sun at just the right angle, while the body stems from a serendipitous alignment of smaller stones and ridges. The rover's low vantage point exaggerated the shapes, compressing perspective to create the illusion of a towering figure. Earth offers parallel illusions. Think of Utah's Bryce Canyon at dusk, where hoodoos cast shadows that writhe like giants as the light shifts. On Mars, with its razor-thin atmosphere and dust-laden skies, shadows grow sharper and more theatrical, stretching far beyond their earthly counterparts. Yet the Guardian taps into something deeper than optical science. Why does Mars feel so watched? Perhaps it's the planet's eerie stillness. A world where winds whistle but nothing stirs, where every rock sits undisturbed for eons. That silence primes us to anthropomorphize, to fill the void with imagined observers. Psychologists call this agent detection, a survival instinct that once helped our ancestors spot predators in the brush. On Mars, it conjures specters from sandstone. Even NASA's own imagery leans into this. The Happy Face crater grins from the South Pole, while boulder fields become crowds frozen mid-gathering. The Guardian is just the latest in a lineage of Martian Rorschach tests. Historically, this impulse isn't new. Early telescopic observers like Percival Lowell mapped canals across Mars, convinced they were engineered by a dying civilization. The Viking landers' 1976 images sparked debates over carved faces and pyramid ruins. Each era projects its own myths onto the red planet, reflecting our collective anxieties and hopes. The Guardian fits this tradition, a digital age phantom born from pixels and pareidolia, yet no less evocative for being debunked. But here's the twist: while the Guardian isn't real, the questions it raises are. How would we recognize true signs of life or intelligence on another world? Our tools grow sharper. AI scans terrain for anomalies, spectrometers sniff out biosignatures, but our biases linger. A future discovery might not announce itself with grand monuments or shadows, but in subtler chemistry or microscopic structures. The Guardian, then, is more than a shadow play. It's a rehearsal for the day we face something truly unexplained. Until then, Mars will keep casting its spectral sentinels, reminding us that exploration is as much about deciphering our own perceptions as it is about reading the rocks. And perhaps that's the real lesson. The universe isn't just stranger than we imagine, it's stranger than we can imagine. So the next time a shadow gives you pause on Mars, let it. Wonder is the first step to discovery, even when the answer is just a rock. High above the Martian surface, clinging to the edge of a towering cliff in the Phobos Monolith region, a single slab of rock stands with such geometric perfection it seems lifted straight from 2001, A Space Odyssey. This is the infamous Mars Monolith, a rectangular formation roughly 5 meters tall, its sharp angles and flat faces glaringly out of place against the chaotic rubble of the red planet. First spotted in 2008 by NASA Mars Reconnaissance Orbiter, the monolith immediately ignited fierce debate. Was this a trick of light and perspective, a fluke of erosion, or something far more extraordinary? At first glance, the monolith's precision feels engineered. Its sides align at near-perfect 90-degree angles, its flat planes reflecting sunlight with unnatural consistency. Conspiracy theorists seized on its resemblance to Arthur C. Clarke's fictional alien artifact, arguing it could be a marker, a beacon, or even a structural remnant of a lost civilization. The location only deepened the mystery, perched precariously on a crater rim, as if deliberately placed. But science offers a humbler, though no less fascinating, explanation: jointed bedrock. On Earth, similar formations arise when tectonic forces fracture rock into geometric blocks. Utah's canyonlands showcase towering sandstone slabs split by natural stress lines, while Iceland's basalt columns form hexagonal pillars so uniform they look carved. Mars, though lacking active plate tectonics, has its own fracturing forces: thermal expansion and contraction from extreme temperature swings, or seismic activity from ancient impacts. Over eons, these stresses could have cleaved bedrock along natural plains, leaving behind this solitary sentinel. The monolith's sharp edges might simply be the result of clean breaks along pre-existing weaknesses, with wind erosion polishing the faces smooth. Yet the debate persists. Why does this one rock stand alone, unburied by dust or debris? Why does it cast such a stark, rectangular shadow? Skeptics counter that orbital images flatten perspective. What looks like a freestanding pillar could be the protruding edge of a larger formation, its base obscured by shadows or dust. Even the perfect angles might be an illusion. High-rise three-dimensional terrain models suggest the monolith's faces are slightly irregular up close. What's undeniable is how powerfully such features captivate us. The monolith isn't just a rock, it's a blank screen for our cosmic anxieties and hopes. The same instinct that saw faces in clouds now projects alien architecture onto Martian cliffs. It's a testament to humanity's hunger for meaning, our refusal to believe the universe is indifferent. And in a way, the monolith is a message not from aliens but from geology itself, a reminder that nature, given enough time, can craft wonders that rival fiction. So while the Mars Monolith likely isn't a stargate or alien artifact, it is something equally valuable, a mirror held up to our own curiosity, proving that even in a desert of dust and rock, the human imagination finds endless fuel. From the haunting face on Mars to the whimsical cosmic Cheerio, the red planet has served up 30 mysteries that defy easy explanation. Each phenomenon, whether a seasonal dark streak, a pyramid-shaped rock, or a ghostly shadow, challenges what we think we know about this rust-colored world. Just when we believe we've unlocked Mars' secrets, it tosses another enigma our way, like a cosmic magician with endless tricks up its sleeve. What's remarkable isn't just the diversity of these puzzles, but how they persist despite decades of rovers, orbiters, and landers. You'd think a planet we've mapped down to the millimeter would surrender its mysteries, but Mars resists. The more data we collect, the more questions arise. Those methane spikes, they come and go like whispers in the wind. The recurring slope lineae, still caught between water and dry sand theories. Even the humble blueberries hold untold stories about Mars' watery past. It's as if the planet thrives on keeping us guessing, reminding us that exploration isn't about checking boxes, it's about embracing the unknown. Perhaps the real lesson here is humility. For all our technology, Mars remains a master of ambiguity, a world where shadows become specters and rocks mimic life. It teaches us that certainty is rare in the cosmos, and that's what makes discovery so thrilling. Every strange light, every geometric formation is a nudge to look deeper, question harder, and stay curious. So now it's your turn. Which of these 30 phenomena gripped your imagination? Was it the towering dust devils, the dragon-scaled poles, or something else entirely? Drop your thoughts in the comments. We'd love to hear which Martian mystery keeps you up at night. And if you're hungry for more cosmic conundrums, hit that subscribe button. The universe is full of puzzles, and we're just getting started.